I'm going to do a set of 3 videos here to go through area, surface area and volume. In the first one, I'm just going to look at area and area conversions. So for the first one, we are looking at how to convert our units. Now, we use a diagram to set up to do this to help us out. So you'll notice that I have on my diagram millimeters squared, centimeters squared, meters squared and kilometers squared. So our units are always with that 2 at the top, the square, because we're looking at 2D shapes. Our measurements, we're looking at 2 dimensions, and we have our 2 at the top there. So when we have a diagram like this, we can set it up and say if we're going from millimeters squared to centimeters squared, or centimeters squared to millimeters squared. Now, I'm going to put these arrows in, going along. You can do them the other way if you wanted to have the arrows pointing in a different direction, having top and bottom. So looking at going from centimeters squared to millimeters squared, if we were going centimeters to millimeters, we would multiply by 10. But because we've got the squared, we need to do 10 squared. Now 10 squared is 100. Meters squared to centimeters squared, if we were just going meters to centimeters, we will multiply by 100. But because we have our squared, we're doing 100 squared. So that means we've got 1,000 that we are multiplying by. I'm not going to be able to fit in my kilometers squared there, but we've got our times by 1,000 squared, and obviously we'd have our 1 with 6 zeros. Going back the other way, so from millimeters squared to centimeters squared, we are dividing. So it's the same number that we have on the bottom, but we are dividing when we're going from a smaller unit to a bigger unit. So I've got my divided by 1,000 there, and then I'll have my divided by 1,000,000. So having a look at this one here, convert 115,000 meters squared to kilometers squared. So I know I'm going to divide. I go up to my diagram, and what am I going to divide by to go from meters squared to kilometers squared? I'm going to divide by 1,000,000. So I'm going to get my calculator, get what I started with, so my 115,000, and I'm going to divide that by my 1,000,000. And I get 0.115. So that will be 0.115 kilometers squared. So whenever you're doing a question like that, go back to your diagram and work out what operation you need to do. Now, when we're doing our area, we need to know a certain number of rules. So that's one of the biggest things when you're preparing for a test on area. Even if you're given a formula sheet, knowing what the shapes are, knowing what the rules are going to make things a lot easier for you. So some that you should know if you're at a grade 9 level, we've got our rectangle is area equals length times width. So that's one you've seen before, but we're assuming you still remember that rule. Square, area is side times side. Triangle, a half of base times height. We added in some last year in grade 8 where we had parallelogram was base times height, and if we look at our little sketch of a parallelogram here, it's got the 2 sets of parallel sides, and you're usually given the height and the base, so it's a little bit of a clue that that's what you're going to be doing, as opposed to our rhombus or kite where we use the same one, and you'll be given your shape and you'll have the internal dimensions, so they're your x and y, because our rhombus or our kite rule is area equals a half xy. So for the rhombus or for the kite, same rule, and you'll see you're given those interior dimensions. Then our circle, you would have seen that in grade 8 as well, area equals pi r squared. The little difference in grade 9 is we add in the sector of a circle, and you may even have seen that last year too. So we have our theta over 360, so that fraction of the circle, pi r squared. And the last one we've got is our trapezium. Area is a half of a plus b times height. And over here, let's add my a at the top, we've got our little diagram of what our trapezium looks like. We've got 2 parallel lines there. We're given the distance between them, and we're given the lengths of those 2 lines. Now I've got a couple of examples to look at on the next page. So at the top here, I've got my trapezium. So when I'm answering these questions, what I would be expecting as a teacher when I'm marking it is to see the following things. So first you would write your rule. And I would be giving you a mark for doing that, or half a mark, depending if you're reading from a formula sheet, etc. Then I would be looking for you to substitute in the numbers that you can see in your diagram. So your A and B are the 12 and 5 in this case. So I would see that written on your page, and then your height is 8. So I would see that. Now, if you need to put an in-between step where you work out that 12 plus 5 and then do the half, you can, or you can put that into your calculator as it is, because we can put either using the fraction and putting a half there, or you could use 0.5, put the bracket, 12 plus 5, and end bracket, and then multiply by 8. So we can type that in as it is on our page, and it will give us the answer of 68. If we did that in stages, we would do the 12 plus 5, we would divide by 2 by finding half of it, and then we would multiply by 8, and see how we get that same 68 again. I'm not looking for those in-between steps necessarily. These are the 3 that I'm looking at, and I lastly want my meters squared because I want my units there. The next one I'm looking at, I can see that it's half of a circle. So rather than having to use the theta over 360 rule, I can just go straight to saying a half of pi r squared because I know I've got half of a circle. So I'd be expecting to see that written down. And then I would put into there a half times pi times, now here I've got 10 across there. That's my diameter. So I might want to write to the side that my radius is equal to 5 meters to show that I know that's how you get the radius. Then over here, I'm going to put that 5 squared in. Now, as I did before, I can enter that in as it is. So I can use my fraction button and write the half. Then I can do times pi for my pi there, and then times 5. And I can use either this little button here that has a squared with it, or I can use the up arrow and put a squared there. So I can put that into my calculator. Now, what you might find is the calculator leaves it in terms of pi. We can go down to this little white arrow key and press across and get that as a decimal. So we get 39.269, so I would probably round that to 39.27, and that's meters squared. In the next example, I'm showing you one where it's not an obvious fraction of the circle for us to work out like we had a half. Here we've got 280 degrees. So I'll set my rule up with my theta over 360 pi r squared, and then I'm going to put in the 280 over 360 times pi times, and my radius here is 5 again, like I used up here, 5 squared. Happen to use the same radius again. Now, like I did before, I can put that into my calculator. So I can press the fraction button, put the 280 over 360, and then I can do times pi times 5 squared. So I've got that in my calculator now. I can press enter, and I get it in that form of pi again. So I'll press my across arrow, and I get 61.086. So I'll round that to 61.09, and we've got meters squared. Now, my lucky last one is when we have a combined shape. Now, sometimes students get a bit confused when they see that and not sure how to tackle it. Always look for what shapes you can see. So I can see here, I've got a rectangle, and here I've got a half circle. So when I work out the area of that, I can say that my area is equal to my rectangle, and you could even draw a picture, plus half circle. And when I know my rectangle rule is length times width, I'll write length times width plus a half of pi r squared. Now my length and width are 12 and 10, so I've got 12 times 10. And then my radius here, I know it's 12 the whole way from here to here, so my radius is going to be 6. So I might even want to write that over here at the start just to remind me. So I've got a half times pi times 6 squared. I'll grab my calculator and pop that in. I'm going to do the 12 times 10 first and put that in. So 120. Just in case I make an error, at least I can see the two parts coming together. So in an exam, if you mess up some of your entering, I can at least see where you have gone with that process. So then I'm going to put my half, and I'm timesing by pi. Oops, need to enter that in properly. 1/2, press the across to get to the next bit, pi times, and my radius this time is 6 squared. So I've got that entered in my calculator. I can press enter. Again, I'm left with it in pi, so I press my little white arrow key there and I get 56.548. So I'll change that to 56.55. Now I need to add those two numbers together. So my 120. Now, because it's on my calculator, I can actually arrow back to previous answers and I can grab that 120 and bring that down, or I can just use what I've got there and do plus 120 and keep those numbers in my calculator. So I get 176.55, and then we have our unit is meters squared. In the next video, I'll go on to surface area, and then in the third video of this series, I'll do volume.